What's up? I'm Vin, and I'm going to go through this integer operations survival packet. And I did provide a link to a copy of this packet in the description below. So you could click on the link and download the PDF. And I would recommend that you read the notes first, then try the questions out. And then whatever questions you get wrong or just don't understand all that much, you could follow along in the video and see what you're missing. Okay, so try this out. And now let's get started. Question 1, we're going to write every integer starting at -8 and ending at +8. So for this one here, what I think about is I think about the number line. Okay, so just imagine the number line. And our number line is going to go all the way from -8 to +8. So the way the integers behave, we have the whole numbers here. So we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is going in the positive direction. We have 0, but then going in the opposite direction, we have the negative numbers. We have -1, -2, then we have -3, -4, -5, and so on. So if we're going to write every integer starting at -8 and ending at +8, what we could do is just know we're going to have -8, then -7, -6, and then this picks up where we left off in the thought process here. Then we have -5, and then we just keep going here. We have -4, -3, -2, -1, 0, and I'll just make a little bit of space here because this is quite a bit of numbers here to write out. So we'll just move these numbers over. But we continue now finally into the positive integers. So then we have 1, 2, 3, 4, 5, 6, and then 7, 8. Okay, so here are all the integers starting at -8 and ending at +8. Question 2, which of these numbers are integers? We have 3.5, -7, 0, 12.2, and -100. So with integers, what we should be looking for is we should be looking for whole numbers. Okay, so we should be looking for whole numbers. Okay, their opposites. Okay, the opposites of the whole numbers. Okay, or 0. So this is what I'm looking for when I go through this list. So 3.5 is not a whole number here. Okay, so this one here would not count because 3.5 has that decimal with the 5 at the end. So we would not include this. -7 does fit the description. Okay, so 7 is a whole number and the opposite of 7 is -7. Then we have 0. 12.2 is no good. We could chop out 12.2. And then -100 is also fine. So these are the numbers in the list that count as integers. Question 3, we're going to label the number line below, then plot the following numbers on that number line. So we have -8, -2, 0, 4, and 9. So let's first start by labeling this number line. So we have, starting here after 0, we have 1, 2, 3, then we have 4, 5, 6, 7, 8, 9. And when we go backwards, we have -1, -2, -3, then we have -4, -5, -6, -7, -8, -9. So -8, we could plot this right over here. Okay, so this would be the location here for -8. -2, we can move over to this spot. We just plot it here. Then we have 0 is lined up here with 0. And then 4 would be over here on the number line. And then 9 would be over here at the end of the number line. Okay, so this would be the correct plotting of these numbers on the number line. Question 4, what is the additive inverse of -14? So when you're looking for the additive inverse, you're looking for the opposite of a number. And the opposite of -14 is +14. And if we remember the definition for additive inverse, in general, we could say that two numbers are inverses of each other if when we do the sum of those numbers, we get 0. Okay, so two numbers that are opposite, when you add them, you get 0. So here we could even check if we did 14 plus -14, this sum would equal 0. So that's why 14 is the additive inverse of -14. And now moving on to question 5 here, which integer has the greatest value? So what I could do here is I can make another number line. So I'm going to draw out a number line. But this time what I'm going to do is I'm going to count by tens. So I'm going to have 0 over here, and then we're going to have -10. Then we'll have -20, -30, and so on. So this will be -40, -50, -60, -70, -80, -90, and then we'll say -100 is over here. So if I plot these numbers here, -100 would be over here, -25 would be in this space here. So that's negative 25. This is negative 100. And then negative 10 is over here. And maybe I'll change colors just so this really pops out. So when we're looking for which number has the greatest value, we want to see which one shows up farthest to the right. Okay, which one here is going more to the right? And that would be negative 10. Okay, negative 10 is, out of these three numbers that we plotted, the most to the right here. So this one, negative 10, has the greatest value. Now, another way to think of this, I find this way helps the concept stick the most, is debt. Okay, so imagine here that you owe $25 or you owe $10, or in the last case, you owe $100. Which one would be the least upsetting? Well, owing $10 would be less upsetting than owing $100. So that's why if you have negative 10 out of these three numbers, that's the greatest amount you could have, the greatest value, because it is more to the right. You're owing less money, which is a better scenario. So that's why, once again, negative 10 is our answer. Question 6, we're going to write the additive inverse of 23. So here we're just looking for the opposite of positive 23. And the opposite of positive 23 is negative 23. So this would be our answer here. And if we wanted to check, we could say that 23 plus negative 23 is equal to 0. Okay, that's what it means for two numbers to be additive inverses, is that when we add them together like this, the number and its opposite, we get 0. So now moving on to question 7 here, we're going to write these numbers in order from least to greatest. Okay, so remember, with negative numbers, think of it as owing money. So when we look at these two numbers here specifically, negative 3 and negative 8, it would be worse if we owed $8 than if we owed $3. Okay, so when do we have the least money in our, let's say, bank account? Well, if we owe $8 here, we would have the least amount of money. If we owed $3, that would be the next best scenario, but still not a great scenario. Then having $0, then having $5, then having $7. Okay, so this would be putting the numbers in order from least to greatest. If we were to draw out a number line, so I'm going to draw this over here, and I'll move it over in this space, and then we'll move the integers over here, we'll move them down. But if we were to look here and plot these, we could see that if we have, let's say, I'll put this over here. So we have 0, and then 1, 2, 3, 4, 5, 6, 7. Okay, and then we go all the way back to negative 8. So we have negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. I'm going to put all the way at the end here. And I'm not going to write every number in between, because the ones we're going to plot here, see how negative 8 shows up all the way to the left. Then negative 3 is next. Then 0 from the list, and then 5, and then 7. So we're basically starting from the left and writing the numbers as they appear until we write the last number that shows up all the way to the right. Okay, so this would be writing the numbers in order from least to greatest. So I'll just box this off here, and this is our solution to question 7. Question 8, we have to fill in the blank with a less than, greater than, or equal to. So here, once again, let's think of the negative numbers as debt. Pretend that for a moment you owe $14, and in another scenario you owe $18. Which scenario is worse? Well, owing $18 is worse than owing $14. So if you owe $14 compared to owing $18, you have more money when you owe 14 than when you owe 18. Okay, so we could say negative 14 is greater than negative 18. If we want to see this with the number line, so I draw out the number line again, and I'm going to put 0 over here. So then we have, let's see, negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we have 11, 12, 13, 14. So this is negative 14 over here. And then we have negative 15, negative 16, negative 17, negative 18. So if we do this, and then I just plot these numbers here. So notice that negative 14 shows up more to the right than negative 18. So that's why we could say negative 14 is greater than negative 18. So that's our solution to 8. Question 9, once again, we could think about in terms of debt. We want to fill in the blank with less than, greater than, or equals. So we have negative 35, we're comparing to negative 13. So here, just imagine you owe $35 versus owing $13. It is worse to owe $35 than it is to owe $13. So if you owe $35, that's having less money than if you owe $13. So we could say negative 35 is less than negative 13. If we want to see this with the number line, just so we could make sense of it with a visual representation here. So I'll draw out a big number line like this. And let's say 0 is over here and I start going into the negatives. Well, I'm going to say that this is -10. I'll say this is -20. This over here is -30. And then this would be -40 over here. If I were to estimate the location of -35, well, I would put it halfway between -30 and -40. So -35 would go over here. -13 would be somewhere in this neighborhood over here. Okay, so almost halfway from -20 to -10, but closer to -10. So this would be the location of -13. And we could see that -35 shows up more to the left than -13 does. So that's why we could say -35 is less than -13. For question 10, we're going to label the number line counting by fives. Then we're going to plot the following numbers on the number line. So notice that we have 0 over here. So then we would have 5, 10, 15, 20, and then 25. Okay, so for questions like this, sometimes we'll look at a vertical number line when we're talking about temperature or maybe sea level. If we're in a scenario where we're going underwater, then we would use a vertical number line to model the situation. So then if we count by fives but backwards, we have -5, -10, -15, -20, and then -25. Okay, so this would be us labeling the number line. And now we just plot everything. So -20 would show up down here. And I can just count again. We have 5, 10, 15, 20, but we're going into the negative here. So that's why we're putting -20 in this spot. 15 would be 3 notches up from 0. So we're going 5, 10, 15 is going to go over here. -5 is going to go 1 notch below 0. And then 0 is going to be already labeled for us. So we just plot the last number here. And this would be the correct plotting of our numbers on this vertical number line. Question 11, we're going to simplify the absolute value of -3. So for these questions, you could just remember that when you take the absolute value of a number, the absolute value will keep positive numbers the same, and it will change negatives to positives. Okay, so the absolute value of -3 is equal to +3. Now, a little bit more of a technical definition is that the absolute value tells you the distance from 0. Okay, so if we're looking at, let's say, absolute value of -3, just imagine -3 is over here, and the absolute value is asking us how far away is -3 from 0? Well, it's 1, 2, 3 units away. Okay, so that's why the absolute value of -3 is +3. Just remember, distance is always greater than or equal to 0. Distance cannot be negative. So when we ask, what is the distance of this number from 0? We're counting the positive space between -3 and 0. So that's why we're getting 3. Question 12, simplify negative and then absolute value of -5. Now, students may look at this very quickly and just say, oh, absolute value makes everything positive, so +5. But no, this is a very dangerous bear trap, okay? We have to be careful here. Just notice what we have. We have a negative, and then we have the absolute value of -5. So I'm just going to write that negative outside of a set of parentheses, and we're going to evaluate what's on the inside first, and then we'll deal with this negative on the outside. So we're going to have negative, parentheses, the absolute value of -5 is +5, and then we have minus, and then we have +5 on the inside. So this just works out to -5. Okay, so one thing to be very careful of, when the negative sign is outside of the absolute value won't make this negative positive. It'll make the one inside positive, but the one on the outside here will stay negative. Okay, so our solution here should be -5. So now we're moving on to the adding integers section. So starting off here with question 1, we're going to do 5 plus 3. And for the first few examples here, I want to use the number line to outline what's going on here. So 5 plus 3, we start at 5 on the number line, and then plus 3 tells us to go forward 3 units. So we go 1, 2, 3, and this tells us that 5 plus 3 is equal to 8. And now we could use the number line again, this time to do 7 plus -5. So when we do 7 plus -5, we start at 7, but instead of going forward 5, we're going to go backwards 5, okay? So we go negative or in the opposite direction. So we go 1, 2, 3, 4, 5, and that brings us to 2. So 7 plus -5 is equal to 2. Now, one thing to think about here, I just want to point out that 7 plus -5 is actually the same thing as doing 7 minus 5. Okay, so 7 minus 5 is equal to 2. That's another way to think about this to get the same answer. Question 3, we have negative 6 plus 4. So now we're going to start at negative 6 and we're going to go forward 4 units. So we're going to go 1, 2, 3, 4, and that brings us to negative 2. Okay, so this is going to work out here to negative 2. Now, another way to think about this is you could look at the connection between negative 6 plus 4 and 6 plus negative 4. Okay, so 6 plus negative 4 is the same thing as 6 minus 4, which is equal to positive 2. So a little mental shortcut that I'll do sometimes is when the bigger number has the negative in front, you could think of it as, let's say in this case, 6 minus 4 is 2, but then you just take the opposite of that and you get the answer here is negative 2, right? And the reason behind this, if we think of the distributive properties, so another thing to think about is negative 6 plus 4 is the same thing as negative 1 times 6 minus 4. Okay, you could see if I send that negative through, negative 1 times 6, we're going to see later in the multiplication section works out to negative 6, and negative 1 times negative 4 works out to positive 4. So we could do 6 minus 4 is 2, but then just throw the negative in front. And that's another way to think of this. Or you could just see the number line in your head and just bounce 4 units to the right. So now for the next one, we have negative 3 plus negative 2. So negative 3, we're going to start here, and I'll change up the colors here. So we have negative 3, and then we're going plus negative 2. So instead of going to the right 2, we're going to go opposite because we're adding a negative, and we go to the left 2, and that brings us to negative 5. And another way to think of this, just think of this as owing money once again. So if you owe $3 and then you add $2 more of debt, well, now if you owe $3 and then you owe $2 more, then altogether you owe $5. Okay, so that's why this would work out to negative 5. So now we'll just go through the others without the number line. So we have 40 plus 25. This is basic addition. We could write off to the side. We could do 40 plus 25 if we don't want to do that math in our heads. And we say 0 plus 5 is 5, 4 plus 2 is 6. So this works out to 65. And now moving on to the next question here, 8 plus negative 4. This is the same thing as 8 minus 4. Okay, so you could think of this as 8 minus 4, which is equal to 4. So we could say that 8 plus negative 4 is equal to positive 4. If you wanted to use the number line here, you could start at 8 and go backwards 4 units to get to positive 4. But once again, you could just think of this as 8 minus 4 and get the same result. So now question 7, we move on here. Think of this once again as debt. You owe $30 and then you add $7 more of debt. So think of, let's just do this on the side. 30 plus 7 is 37. However, we are in the negative. If we owe $30 and then we add $7 more of debt, then we owe $37. So we have negative $37 to our name. Okay, so now moving on, we get to question 8. We have negative 10 plus 15. So for this one, what's interesting, if you just see that this is going to be equal to 5 at the end, then excellent. Okay, if you could just see, if I just draw out the number line, if we have negative 10, and let's say I count by 5. So I have negative 5, 0, 5, 10, 15. So if I start at negative 10 and I add 15, so that's 5, 10, 15, that's going to bring us to 5. But I also want to point out off to the side here that negative 10 plus 15 is the same thing as, and I'm going to use the commutative property of addition, it's the same thing as 15 plus negative 10. Okay, with addition, you could switch the order of the numbers that you are adding. But when I write a negative integer after the plus sign, it's nice practice to put that integer with the negative in front in parentheses, kind of like how you see over here with these questions. So then we could see that 15 plus negative 10 is the same thing as 15 minus 10, which is also equal to 5. So that's another reason why our answer works out to 5. Question 9, we've got negative 20 plus 13. So for something like this, what I'm thinking of is I'm thinking of 20 minus 13. So I'm doing 20 minus 13 is 7. However, this is flipped here. Notice the negative is attached to the 20, not the 13. So in this case here, we would get negative 7. Okay, this is going to work out to, we're going to have negative 7. And remember, the more technical way to think of this, so this is using more theory here, is when we have negative 20 plus 13, this is the same thing as we could take the minus out, and that's going to switch the sign of everything here. So we have minus parentheses 20 minus 13. Okay, so this is just another way to think of this in a more technical way that's going to give us negative 7. So now question 10, we have 15 plus 7, and we're dealing with the sum of two positive integers. So for this one here, we could just add these two together, and we get 22. Okay, so that's our solution for 10. And now next up, we have 50 plus negative 23. So for this one, another way to think about it is when you have 50 plus negative 23, this is the same thing as 50 minus 23. Okay, so we can do this long subtraction on the side here. And we're going to borrow from the tens place here. So we turn this into a 4. And we put a 1 here. And then we have 10 minus 3 is 7. 4 minus 2 is 2. So for question 11, we get 27. Question 12 is that concept of the additive inverse. When you add two opposites, the opposites cancel out and give you 0. Okay, so this would also be true if we had 7 plus negative 7. This would also give us 0. But the way it's written right now, negative 7 plus 7, we could just say is equal to 0. So looking at question 13, when we have 75 plus negative 75, these two here are opposites. They are additive inverses. So this sum is also going to equal 0. Question 14, we have negative 33 plus 16. And for questions like this, one little trick I do is I look for which number has the negative. Is it the bigger number or the smaller number? So since 33 is bigger than 16 and it has the negative, that tells us the sum is going to work out to a negative. Okay, and then we could just do on the side 33 minus 16 to see how much they're off by. So now I borrow here, I turn this into a 2. We have 13 minus 6 is 7. 2 minus 1 is 1. So this sum works out to negative 17. Okay, and remember from before, one other way to think of this is you could say this is minus parentheses and then change the sign of everything. You get 33 minus 16 like this. And when you do 33 minus 16, you get 17. With the minus in front gives you negative 17. Okay, so I'll just get rid of this. Let me rewrite that 0 from before. And now we're going to move on to question 15. So earlier in the video, I talked about how when you add two negatives, this is like building up debt. Okay, if you owe $20 and then you borrow another 80, then you owe another 80. So if you owe 20 and then you owe another 80, you're going to owe 100. But owing is negative, so we would have negative 100 here. Okay, or just think of this as 20 negatives plus 80 negatives is 100 negatives. Okay, but either way, we're getting negative 100. And now for the next question here, so for question 16, we have 75 plus negative 125. And for this one, we could use commutativity of addition. And if you could just do this math in your head and you get right to the last step here of negative 50, then great. Otherwise, what you could do is you could call this negative 125 and then plus 75, and then use this idea from before that when you have these two numbers here, this is the same thing as taking out the negative, and then you have 125 minus 75. Okay, when I take out the negative, the signs just change here. And if I do that math on the side, 125 minus 75, 5 minus 5 is 0, and 12 minus 7 is 5, so we get 50. But with the minus in front, that gives us negative 50. So now we got question 17. I'll just move this stuff out of the way here. So now we're just adding 28 plus 34. So we have two positives here. So when we add these together, we could just do the long addition. We have 8 plus 4 is 12, carry the 1. 1 plus 2 plus 3 is 6. So we get a sum of 62. And now for the next question here, question 18, notice that we have negative 48 plus 19. And for this, we could take out the negative in front. And then what we have left in the parentheses here is the opposite. So opposite of negative 48 is positive 48. And then opposite of, I'll just make this a little neater, but opposite of positive 19 is negative 19. So what we're really doing here is we're doing 48 minus 19 and then throwing a negative in front. Okay, so we borrow here, we make a 3, we put a 1 here for 18, and then we have 18 minus 9 is 9. 3 minus 1 is 2. So the difference here is 29, but we have the minus here, so we have minus 29. Okay, so one thing that really helps for questions like this is you just think here, if 48 minus 19 equals 29, then the flip, 19 minus 48, is equal to negative 29. Okay, so this works all the time in math. This is a very interesting property that comes up. So that's why it's good to look at these examples in bulk. Question 19, we have negative 40 plus negative 23. So for this one, we're adding two negatives here. So this is once again like owing money. So if you owe $40 and then you borrow another 23, you're building your debt even higher. Okay, so we'll just add together the absolute value of the numbers. So when we do 40 plus 23, this will tell us how much money we owe altogether if we think about it in a real world context. So we would get 63 for the sum, but we're adding two negatives, so we're going to get negative 63. Okay, if you have 40 negatives and then you add another 23 negatives, in total you have 63 negatives. Question 20, we're doing 100 plus negative 42. And this is the same thing as 100 minus 42. So off to the side here, I'll just do that subtraction. So we have 100 minus 42. And for this one here, we could borrow from this 10 and make it a 9. Put a 1 here. 10 minus 2 is 8. And 9 minus 4 is 5. So the difference here is going to be 58. So we could say 100 plus negative 42 is equal to 58. And now for question 21, we're adding two negatives. So we could just add the absolute values of the numbers, and then at the end, just put a negative in front. So I'm going to do 35 plus 47. And for this, we have 5 plus 7 is 12, carry the 1. 1 plus 3 plus 4 is 8. So we get negative 82. Question 22, we have negative 20 plus 12. So for this one here, what we could do is we could put the minus in front, and then we change the sign of each of these numbers. Okay, so we have here negative, and then we have positive 20 and negative 12 on the inside like this. So we're doing 20 minus 12 on the inside with the minus in front. So when we get to the end here, we're going to have minus 20 minus 12 is 8. So our solution is negative 8. Now just know the property that I'm using here, this is the distributive property. Okay, so this is from the notes earlier in the packet, but the distributive property tells us that we are allowed to do this. Question 23, we have 31 plus negative 42. And for this one, if we can't do the math in our head, what we could do is we could write the number with the bigger absolute value first. So we could say negative 42 and then plus 31. And then from here, what we could do is we could take that minus out, just like we did in the previous question, and we could write 42 minus 31. Okay, so negative 42 plus 31 is the same thing as negative, and then parentheses 42 minus 31. And if we do that subtraction, this is going to work out to 11. So we get the sum here of the original 31 plus negative 42 is equal to negative 11. Now finally, the last example for the addition section here, we have negative 85 plus negative 17. And for this, if we have 85 negatives plus another 17 negatives, we could work out this sum here and then just say the sum with the minus in front. So 5 plus 7 gives us 12, carry the 1, and then 1 plus 8 plus 1 is 10. So we get 102. But since we're adding two negatives here, we're going to get negative 102. So now we're moving on to subtracting integers. And first up, we have 8 minus 3. So we're going to start at 8, and then 8 minus 3 tells us to go left 3 units. So we're going 1, 2, 3, and this is going to land us at 5. So 8 minus 3 is equal to 5. So when we have something like negative 1 minus 5, now we're going to start at negative 1, and minus 5 tells us to go to the left 5. So we're going 1, 2, 3, 4, 5. And this brings us to negative 6. So negative 1 minus 5 is equal to negative 6. And now for something like 2 minus negative 4, this is where things get a little bit tricky. But just know, anytime you subtract a negative, this is the same thing as saying 2 plus 4. Okay, so we're going to start over here at 2, and we're going to go to the right 4 units. Now, the reason for that, think of this as when we say minus, we're going left. But then the negative tells us to go opposite. So we're going left opposite 4 means we're not going to be going to the left 4. We're going to be going to the right 4. Okay, or if you just want to remember that minus minus changes to a plus like this. So we're going 1, 2, 3, 4, and this is going to bring us to 6. So next up, question 4, we have negative 3 minus negative 5. So we're starting over here at negative 3, and just remember from before, when we have subtracting a negative, we're going to do negative 3 plus 5, okay? Subtracting a negative, we change that to addition. So minus minus goes plus. And now we have negative 3 plus 5, so we're going 1, 2, 3, 4, 5. So negative 3 plus 5 is equal to 2. All right, this is just the mental model that I have anytime I'm adding or subtracting integers, is I just imagine a ball of some sort just bouncing along the number line. Okay, so now we're going to go without the number line for the remaining questions here. So next up, question 5, we have 25 minus 40. And for something like this, the math that I do in my head is I subtract these two numbers, but I write the bigger number first. So I do 40 minus 25 in my head is 15. But when I'm subtracting a bigger number from a smaller number, I know that difference is going to be negative, and the difference between them is 15, so we're going to get negative 15. And now we can move on to question 6. So for something like this, when we have negative 10 minus 12, this is the same thing as saying negative 10 plus negative 12. And remember before when we were doing adding integers, I talked about owing money. If you have negative $10, it's like owing $10. And then if you owe another $12, you would add those together and keep the negative. So you would have, you're doing 12 plus 10 is 22. So you would have negative $22 if you're talking about debt. Question 7, we have negative 12 minus negative 5. So the first thing we could do is write negative 12 plus 5, because when we subtract a negative, we could change those two minuses to a plus. And now there's a few ways we could think about this question. When you have negative 12 plus 5, that's the same thing as saying 5 minus 12. And you could also, for something like this, find the difference between 12 and 5. 12 minus 5 is 7. But since the minus is attached to the 12, we're subtracting a bigger number from a smaller number. The difference is going to be negative, and those numbers are 7 units away. So that's why we're going to get negative 7. Okay? Or if you could just think of the number line, negative 12 plus 5, if you could just see, the number line, something like this, you're at negative 12, and you bounce forward 1, 2, 3, 4, 5, that you're going to land at negative 7. So there's a lot of different ways you could work through these, but being able to move the expressions around from one form to the other is going to help you get really good at this stuff. So now, next up, question 8, we have 30 minus negative 15. So first, I'm going to write 30 plus 15, and now we have the sum of two positive integers. So 30 plus 15 is just equal to 45. So we could say that this is all equal to 45. So next up, we have 65 minus 72. And for something like this, I'm just going to do 72 minus 65. And I know these two numbers here are 7 units away. So for something like this, 65 minus 72 is going to be negative 7. Okay, so this is a trick I like to use. I like to do the corresponding subtraction problem with the bigger number first, and then I just put a negative in front like this. Okay, so for something easy, let's say I have something like, let's say 10 minus 8 is equal to 2. Then if I say 8 minus 10, that's equal to negative 2. So that's the idea that I'm going to be using here throughout. And now we're moving on here. Question 10, we have negative 60 minus 50. So if you just know to add those two numbers and that you're going to get negative 110, then great. Otherwise, the in-between step is to say negative 60 plus negative 50. And if I have 60 negatives and then 50 more, then I have 110 negatives in total. Now, next up, question 11. We have negative 33 minus negative 12. The minus we can turn into a plus sign. So now we have negative 33 plus 12. And same idea as before. When we are doing negative 33 plus 12, that's the same thing as saying 12 minus 33. So I could just do 33 minus 12, which is equal to 21. So we're going to get here, this sum is going to be equal to negative 21. Okay, if it was positive 33 minus 12, then it would be plus 21. But when we reverse it and have minus 33 plus 12, we're going to get negative 21. And now moving on to question 12, we have negative 5 minus negative 5 is going to give us negative 5 plus 5. And these two here are additive inverses. So this sum here is going to work out to 0. When we add a number and its opposite, we get 0. So next up, let's see, question 13. So question 13, we have 13 minus negative 19 is going to become 13 plus 19. And if you could work this sum out, then great. Otherwise, just do the long addition on the side. 9 plus 3 is 12. So we have a 2, carry the 1. 1 plus 1 plus 1 is equal to 3. So we're going to get 32. Okay, so 32 for question 13. Question 14. So now we've got 50 minus 16. So this one is just, us doing long subtraction on the side here. So this one is nothing too fancy. It's one of the nicer examples. So we can't do 0 minus 6. So we're going to borrow here and make the 5 into a 4, put a 1. 10 minus 6 we could do is 4. 4 minus 1 is 3. So this difference is equal to 34. All right, now moving on. Question 15. We've got negative 33 minus 28. This is the same thing as saying negative 33 plus negative 28. And for something like this, we could just do the addition on the side here. So we add these numbers. 3 plus 8 is 11. So we write a 1 and we carry the 1 in the tens place. 1 plus 3 is 4. 4 plus 2 is 6. So this sum here is going to work out to negative 61. Okay, just don't forget to transfer the negative because we're dealing with the sum of two negatives here. Now, question 16, we are subtracting 200 minus 136. So that I'll just write, in this space here, 200 minus 136. So we're going to borrow from the hundreds place. We have a 1, and then we're going to transfer it over here. And then we're going to have to borrow again. So we're going to turn this into a 9. And then this 1 carries over to the ones place. 10 minus 6 is 4. 9 minus 3 is 6. 1 minus 1 is 0. So we don't have to write it in the hundreds place. So the difference here is equal to 64. Question 17, we have negative 24 minus 23. So for this, we could write negative 24 plus negative 23. And we could just do this sum on the side. We could do 24 plus 23. And 4 plus 3 is 7. 2 plus 2 is 4. So we're going to get negative 47. Question 18. We've got negative 48 minus negative 15. So this difference we could write as negative 48 plus 15. Remember, minus minus changes to plus. And now we could think of this a few different ways. So negative 48 plus 15, that is the same thing as saying 15 minus 48. And for something like this, I would prefer to do 48 minus 15. And we're going to get 8 minus 5 is 3. 4 minus 1 is 3. But my difference here is going to be negative because I'm subtracting a bigger number from a smaller number. Okay, so this difference is going to work out to negative 33. All right, so once again, one of the big ideas for integers is being able to look at something like this, negative 48 plus 15, and knowing that it means the same thing as 15 minus 48. And then this you could even think of as saying, all right, what's the difference between 48 and 15? And then I just put a negative sign between them. Right, so that flexibility of being able to jump from one form to the other is very, very, very important for integers. So question 19, we have 40 minus negative 23. So we could write 40 plus 23 because we have minus minus going to plus. And now we just add these two numbers together. 40 plus 23 is equal to 63. All right, next up, question 20, 24 minus 42. So on the side, I'm going to do 42 minus 24. And here I'm going to borrow. So we have a 3, carry the 1. 12 minus 4 is 8. 3 minus 2 is 1. But we're subtracting a bigger number here. So we're going to get a negative. And we have negative 18 is our answer. Question 21. Question 21, we've got negative 15 minus negative 21 is going to change to negative 15 plus 21. And now this we could think of a few different ways. So we could also just use commutativity here and even say that this is 21 plus negative 15, which is equal to 21 minus 15. And if we do 21 minus 15, we're going to get 6, which is our answer to question 21. All right, next up, question 22, we are doing negative 45 minus 45. Now, be careful here. Don't write something like 0. Okay, 0 is a very dangerous bear trap. For this, we just have to be very careful. Notice that we're doing negative 45 minus 45. If we had negative 45 minus negative 45, then we would get 0. But that's not what we're dealing with here. We're doing negative 45 minus 45. So we have negative 45 plus negative 45. That's really what's happening here. And if I have 45 negatives and then I get 45 more negatives, then I have 90 negatives total. So negative 45 minus 45 is equal to negative 90. Question 23, though, which is exactly what I was talking about from before. In this case, we have negative 45 plus 45 because when we subtract a negative, the operations here change to addition. And then negative 45 plus 45 is equal to 0 because these two numbers here are additive inverses. And now, last but not least, we have 45 minus negative 45. So when we have minus minus, that these two subtraction signs here, or I'm sorry, this is, let me point something out. This one here is subtraction. Okay, and this one is a negative sign. So I just want to point out the difference between them because in a way, this will segue very well to the multiplication section. We could think of this as 45 plus -1 times 45. Okay, so this minus sign is more like, hey, what's the difference between these two numbers? Whereas this one, the negative, is more similar to saying -1 times the number like this. Okay, so this is also important for when you move on to algebra. If you have to type things in the calculator, calculators will often have a subtraction and a negative sign. So they're just like a different notion. So here, though, let's work this out. 45 minus 45 changes to 45 plus 45. And this sum here is going to be equal to 90. And that's our solution to 24. So now we're moving on to multiplying and dividing integers. And first up, we have -3 times 4. So for something like this, just know anytime you multiply two integers with different signs, the product or quotient is going to come out to a negative. So here, the math that I'm doing in my head is I'm just thinking of my times tables. I'm thinking of 4 times 3 is equal to 12. But since I'm multiplying -3 times 4, I'm going to get a product of -12. Okay, so now moving on to question 2. Question 2, we have -6 times -2. And anytime you multiply two negatives, you're going to get a positive. And the same thing is true when you divide two negatives. The quotient of two negatives is also positive. So here, the math that I'm doing 6 times 2 is 12. So when I do -6 times -2, I'm also going to get positive 12. And now we can move on to question 3. So question 3, we have 20 divided by -5. So the first thing I look for is the sign. So I'm doing a positive divided by a negative is negative. And then I just think, what is 20 divided by 5? 20 divided by 5 is equal to 4. So this quotient here works out to -4. Okay, so remember, when you divide a positive by a negative, you get a negative. If you divide a negative by a positive, like in question 4, you are also going to get a negative. Okay, so moving on to question 4, we're going to have here -108 divided by +9 is negative. And now we just have to know 108 divided by 9. So 108 divided by 9 is 12. If that math is a little annoying to do in your head, you could always do long division. 9 goes into 10 once. 1 times 9 is 9. We subtract, remainder 1. And then we bring down the 8. 9 goes into 18 twice. 2 times 9 is 18. So we get even division here. So we're going to get -12 here for our quotient. Okay, so it really helps to know your times tables in and out because that'll really help you with your multiplication and division as well. So now moving on here, we have 7 times -3. Just know when you see parentheses in math, parentheses means multiply. So we're doing 7 times -3. And since we're multiplying a positive by a negative, we're going to have a negative product as our answer. And then 7 times 3 is 21. Question 6, we have -9 divided by -3. So for this one, we're dividing two negatives, so the quotient is going to be positive. And now we just think, what is 9 divided by 3? 9 divided by 3 is equal to 3. So for this question here, we're going to get +3 as our answer because, once again, we're dividing two negatives. Question 7, we're just doing 12 times 11. 12 times 11, we just grab right from the times tables, is equal to 132. If you forget this product, there's no shame in it, but you just have to be able to do long multiplication. So 1 times 2 is 2, 1 times 1 is 1. We put a placeholder, 1 times 2 is 2, 1 times 1 is 1. And now 2 plus 0 is 2, 1 plus 2 is 3, and the 1 carries down. So we still get 132. Next up, we have -5 times -10, okay, for question 8. And remember, parentheses means multiply. Okay, don't do -5 minus 10. That's a common mistake. Parentheses tells you to multiply two integers together. So here we have a negative times a negative is positive, and then 10 times 5 is equal to 50. So we're going to have +50 as our answer. Question 9, we have negative and then 20 divided by 5. Now, one thing I want to point out here, -20 over 5 like this, we could write the negative in a few different places. So we could have it in front like this. We could also have -20 divided by 5. And we could also say 20 divided by -5. I just want to point out that these three expressions are equal to each other. So whichever one helps you make sense of this more, that's the one you're going to think about as you're doing this. So let's say here I just call this negative 20 divided by 5. Well, before we said when we divide a negative by a positive, we get a negative. The only way to get a positive out of this would be if we did a negative divided by negative. Okay, but there's only one minus sign here, so that's why our answer comes out negative. And now we just do 20 divided by 5 is 4. So this fraction here simplifies to negative 4. And now I had just mentioned it before. Once again, the fraction negative and then 20 over 5 is equal to negative 20 over 5. And this is equal to negative 4. So we could actually say that all three of these are equal to negative 4. So negative 20 divided by 5 is negative 4. 20 divided by negative 5 is also negative 4. Okay, another way to see question 9, so I'll write it out one more way. Negative 20 over 5, that's the same thing as saying negative 1 times 20 over 5. And if we work this out, that's negative 1 times 4, and negative 1 times 4 is, once again, negative 4. Next up, question 12, we have 7 times 6, and that we just have to know our times table. 7 times 6 is 42. Moving on to question 13. So question 13, we have negative 8 times 12. Remember, parentheses means multiply. When you multiply a negative integer by a positive integer, you're going to have a negative product. And then you just have to know that 8 times 12 is 96. If you forget that times table, then on the side, you're going to do long multiplication. You're going to say 8 times 2 is 16, carry the 1. 8 times 1 is 8, plus 1 is 9. So that's where the 96 part is coming from. So next up here, question 14. We've got 45 divided by negative 5. So we're doing a positive divided by a negative. So that quotient is going to come out negative. And then we just have to think here, what is 45 divided by 5? And 45 divided by 5 is 9. And the reason that's true is because 9 times 5 equals 45. So if you struggle with division, the key is to think about the corresponding multiplication fact, and that helps you get better at division. Okay, so here, we're going to have this is equal to negative 9. Question 15, we have 6 times negative 8. Well, for this one, we have a positive times a negative is negative, and then 6 times 8 is 48, so our answer is negative 48. Next up here, for question 16, we are doing negative 12 times negative 15. So we have a negative times a negative is positive, and then for this, we work this out, and we're going to get 180. Okay, and if this is math that you're like, wait, I don't think I could do that math in my head, the key to having this kind of mental math is when I do 12 times 15, I'm actually in my head doing 15 times 10 plus 2. So I do it in pieces, and then I say 15 times 10 is 150, because I just put a 0 at the end, and then 15 times 2 is 30, and then in my head I do 150 plus 30 is 180. If you have to, there is no shame in this. You just do 15 times 12 on the side. 2 times 5 is 10. So we put a 0, carry the 1. 2 times 1 is 2, plus 1 is 3. We put our placeholder. 1 times 5 is 5. 1 times 1 is 1. And we add all this up, and we get 180. Same answer. Question 17, we have negative 20 divided by negative 2. So we're dividing two negatives, so the quotient is going to be positive. And then we just have to know that 20 divided by 2 is equal to 10. So our answer works out to positive 10. Now, next up, question 18, we have 56 divided by negative 14. So since we are dividing a positive by a negative, our quotient comes out negative. And then we just have to know 56 divided by 14 is equal to 4. Now, if you're like, wait a minute, the times tables doesn't go up to 14. How am I supposed to know that? On the side, you could just kind of start counting by 14s. Like you could just start, all right, 14. 14 times 2 is 28. And then if you have to, you could do 28 plus 14 to go next, and that'll bring you up to 42. And then you do one more, and that's going to bring you up to 56. So sometimes you have to do a little bit of investigating for these questions. But in this case here, question 18, our answer is negative 4. Next up, question 19. So here we have 0 divided by negative 5. So 0 divided by negative 5 is equal to 0. Okay, so 0 divided by negative 5 is equal to 0. So for question 20, negative 5 divided by 0 must also be equal to 0. No, this is a very, very, very dangerous bear trap. Just know, anytime you divide by 0, the expression is undefined. Negative 5 divided by 0 is undefined. Okay, so that is a pretty cool concept in math that we could explore very deeply here. one way to get you to understand like why that's the case is, let's say I have 0 to 8 and I say 8 divided by 4 is equal to 2. What that means is if I want to cover 8 and I have pieces that are 4 units long, it's going to take 2 of those pieces to cover 8. But if I do, let's say I'll do 8 divided by 0, the problem with this is if I have pieces that are 0 units long, and I'm like, all right, how many of those am I going to need? Let me just change colors here. How many of these pieces am I going to need to cover this? Well, I'll just keep bouncing at 0 forever. I will never, ever, ever, ever get to 8 if I have to cover this distance with pieces that are 0 units long. So this idea is that, wait, I'll be bouncing here forever, so the quotient is undefined. Okay, you explore this more later in math. This is actually a really cool idea to get into, but for now, just remember, dividing by 0 is undefined. 0 divided by a non-zero is equal to 0. Okay, so next up though, if we multiply by 0, the product is always equal to 0. So here we could say 0 times negative 3 equals 0. And for question 22, negative 7 times 0 is equal to 0. So for this, the order doesn't matter, but division, it absolutely does. Next up, we have question 23. So we have negative 625 divided by 25. So we're dividing a negative by a positive, so the quotient is negative. And then 625 divided by 25 is 25. Okay, so this is just one of the perfect squares. And if you had to, just see on the side, 25 times 25 is equal to 625. So I'll just work this out. 5 times 5 is 25, carry the 2. 5 times 2 is 10, plus 2 is 12. Placeholder, and then 2 times 5 is 10, and we carry the 1. And then 2 times 2 is 4, plus 1 is 5. And if we work this out, 5 plus 0, so I'll just write this sum off to the side over here. So let me just move this stuff over so we could actually see it. So if we work this sum out, we have coming up here, 5 plus 0 is 5, 2 plus 0 is 2, and 1 plus 5 is 6. So this one definitely checks out. And now the last one here for the multiplication division section is we have negative 1,000 divided by negative 100. So the quotient here is going to be positive because we're dividing two negatives. But there's a nice trick. Anytime you divide numbers that have zeros at the end like this, you could cross off common zeros. So there's 2 zeros here. I could cross off 2 zeros here. And I'm left with 10 over 1, which is just equal to 10. So this works out to positive 10. So for the next section, we're working on order of operations. And the thing to know here is PEMDAS. A fun way to remember this, we could say, please excuse my dear Aunt Sally. And what this actually stands for is it tells us when we have a bunch of operations in one expression, we should do parentheses first, then exponents, then multiplication, division, and then addition, subtraction. So let's go ahead and start here with question 1. For question 1, we have 3 plus negative 2 times 5. So when you read this, I'll just transfer this over here. When you're doing question 1, what you want to think about is the operations involved. We have addition and we have multiplication. And when we think of this mnemonic here, we could see that multiplication shows up before addition. So when we work this out, we're not going to do the addition first. We're going to multiply first. We're going to do negative 2 times positive 5 is negative 10. And then we move on to the addition. So now we say 3 plus negative 10 is equal to negative 7. And this is our solution to 1. So now for question 2, we have 8 minus 3 times 2. And we could think of the order of operations again. We could think of PEMDAS. And this time around, what we have is we have subtraction and we have multiplication. So in this case here, we're going to do the multiplication first. So we're going to have 8 minus, and when we do 3 times 2, we get 6. And 8 minus 6 is equal to 2. Question 3, we have 4 plus negative 7. And this question could go in the addition of integers section. But I just want to point out that 4 plus negative 7 is the same thing as 4 plus negative 1 times 7. And in a scenario like this, we would multiply first and say 4 plus negative 1 times 7 is negative 7. So we could say this equals 4 minus 7. And 4 minus 7 is negative 3. So the order of operations concept here is really nice because it allows us to be flexible to turn an addition of integers question into a subtraction of integers question. So it allows us to sort of bounce back and forth between the different forms. Next up here, question 4. what we have is we've got 2 times parentheses 5 minus 9. So remember, in order of operations, when we have PEMDAS here, we do the parentheses first. So we're going to do 2 times 5 minus 9 is negative 4. And now we could multiply since multiplication shows up after parentheses. And 2 times negative 4 is going to give us a product of negative 8. So next up, question 5, we have the absolute value of negative 6 plus 4. So for this one, if we remember from earlier, when we have absolute value of negative numbers, we just write the opposite outside like this. If we had the absolute value of 6, we would also just say 6. But absolute value of negative 6 is equal to 6. And then we have 6 plus 4. And 6 plus 4 is equal to 10. For something like this, though, just be careful. Don't do something like negative 6 plus 4 is negative 2 and then find the absolute value of negative 2. Okay, so this is not what we're going to do here. This would be true if we had absolute value of negative 6 plus 4. Then the absolute value bars, in a way, act as a pair of parentheses. And then we would say absolute value of negative 2, which is equal to positive 2. Okay, but that's not what's happening here. Question 5, we do the absolute value part first and then add 4. So we get 10. So let's see. Next up, question 6, we have 12 divided by negative 3 plus 7. So order of operations tells us that we are going to divide before we add. Okay, so we're going to do the division first. And 12 divided by negative 3 equals negative 4. And then we have negative 4 plus 7. And negative 4 plus 7 is equal to positive 3. Just know negative 4 plus 7 is the same thing as 7 plus negative 4. And 7 plus negative 4 is equal to 7 minus 4, which once again is equal to 3. Question 7, we have negative 2 squared plus 5. And for this one, we're doing parentheses exponents first. So notice that we have negative 2 in parentheses squared. So that's what we're going to do first in this question before we add the 5. So we're going to have negative 2 squared is equal to positive 4. And if that concept doesn't make sense, the idea of an exponent is that when you have negative 2 to, let's say, the second power, that tells you to multiply negative 2 by itself 2 times. And negative 2 times negative 2 is positive 4. So that's why this question here is going to start off as 4 and then plus 5. We do the addition after, and 4 plus 5 is equal to 9. I just want to point out, if we had something like, let's say, negative 2 to the third power, this would be equal to negative 2 times negative 2 times negative 2. And then we could pick any pair to multiply together first, but let's say we multiply the first two together. Negative 2 times negative 2 is positive 4, and then we have positive 4 times negative 2 is equal to negative 8. Okay, so one nice thing, when you're doing a negative base to an even power, so notice this power here is even, you get a positive number at the end. I'll just abbreviate positive like this. And when you have negative 2 or negative base to an odd power, the result comes out negative. Okay, so this is just something to be on the lookout for questions like this. But for question 7, we should have 9. So now next up, question 8, we have negative 3 squared minus parentheses 6 plus 4. Now for something like this, it is very tempting to say negative 3 squared is equal to positive 9. But be careful, this is a very, 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 very dangerous bear trap. I just want to point out that negative 3 squared in parentheses is equal to 9. But negative 3 squared like this is not equal to 9. This is the same thing as doing negative 1 times 3 squared. And when I do this, I have to do the exponent first. So I do negative 1 times 3 to the second power is 9. And this actually works out to negative 9. Okay, so when I work this question out here, I actually have to start off by saying negative 9, not positive 9, because there's no parentheses here. Okay, the parentheses makes the world of difference. However, I will respect the order here. In order of operations, when we have PEMDAS, we are doing parentheses, then exponents later. So we'll work this part out first. 6 plus 4 on the inside is equal to 10. Okay, so we're going to be subtracting 10. But once again, this first part, minus 3 squared without parentheses is equal to minus 9. So far, this question works out to negative 9 minus 19, which is the same thing as negative 9 plus negative 10, which is equal to negative 19. Question 9, we have 2 times in the brackets here, 3 plus negative 7 in parentheses. And then outside the brackets, we have minus 4. So for this one, we are using order of operations again. But I just want to point out that brackets and parentheses are the same idea in math. However, we use brackets when inside the brackets, we already have something in parentheses. And they do this just so that it looks neater, because if you have too many sets of parentheses, the expression could look kind of cluttered. So here we have inside the brackets, 3 plus -7. So that's what we're going to do first. We have 2 times 3 plus -7 is -4. And then we have -4 on the outside. So now 2 times -4 we're going to do next, because multiplication shows up before subtraction. 2 times -4 is -8. And then we have -8 minus 4. This is the same thing as -8 plus -4, which is equal to -12. Question 10, we have absolute value of -12 plus parentheses 8 minus 15. And for this one, I just want to point out that absolute value, in a way, acts as its own set of parentheses. So we could evaluate this one first here, and we'll get the same result. So the absolute value of -12 is equal to +12. And then we have plus, in this parentheses, 8 minus 15 is -7. And now this we could think of as 12 minus 7, which is equal to 5. And that's our solution to 10. Question 11, we have -3 to the third power plus 10. So let's look for the trend here. -3 to the second power is the same thing as -3 times -3, which is equal to +9. But when we do -3 to the third power, now what we're doing is we're doing -3 times itself 3 times. And we just saw a moment ago, -3 times -3 is +9. So we get +9 times -3, which is equal to -27. So for this question, we are using order of operations, but we have to make sure that we do the parentheses exponents first. So now I'll write the solution over here. We're going to say that this is equal to -27. That's -3 to the third power, and now plus 10. And just like we saw before, when we are adding or subtracting integers, something like -27 plus 10, that's the same thing as thinking of 27 being subtracted from 10, okay? So -27 plus 10 is the same thing as 10 minus 27. And for that, we could just do 27 minus 10 is 17, but then just remember to throw a negative in front when the numbers are flipped, okay? So -27 plus 10 is -17, and that's our solution to 11. So next up here, question 12, we have 5 times parentheses -2 plus 6, and then outside the parentheses -8. So for this one, once again, we are using order of operations. And first, we're going to be looking inside the parentheses. So we're going to have 5 times, and now we're doing -2 plus 6 is +4, and then the -8 is going to stay on the outside. And then after this, what we have is we have multiplication and subtraction. So notice that multiplication shows up before subtraction in this letter arrangement here. So that's the operation we are going to do next. We're going to multiply. So 5 times 4 in the next line is 20, and then we have 20 minus 8. So we just work this out. 20 minus 8 is equal to 12, and that's our solution. Question 13, we have absolute value of -4 squared minus 20. And the first thing we should notice here is that the -4 squared does not have parentheses. Remember, -4 squared in parentheses is equal to +16, because -4 times -4 is equal to +16. But when we have something like this, -4 squared without parentheses, we have -1 times 4 squared, and we do the exponent first. So we have -1 times 16, which is -16. So now we could go ahead and evaluate this. We have absolute value of -16 and then -20. And for this one, this is the same thing as -16 plus -20. And if we have 16 negatives and we add 20 more negatives, that's 36 negatives. So we have absolute value of -36, which is equal to +36. Question 14, we have 24 divided by 3 times 2 in parentheses plus -5. So for this one, once again, we are doing order of operations, and 3 times 2 is in parentheses, so we could do that first. So we have 24 divided by 3 times 2 is 6, and then we have plus -5 at the end. But now we look at this expression and notice that we have division and addition. So we're going to do the division first because that shows up first here. So we do 24 divided by 6 is 4, and then we have 4 plus -5, which is the same thing as 4 minus 5, which equals -1. Okay, so we could say here that this entire expression equals -1. Question 15, we have in parentheses -18 divided by 3, and then times -2. So order of operations, we're going to do parentheses first. So in this parentheses, we have -18 divided by 3, is -6 because we have a negative divided by a positive is negative. And then we have times -2 at the end. And when we multiply two negatives together, we get a positive, and 6 times 2 is 12. So this works out to positive 12. Question 16, we have absolute value of -8 plus 3, then times 2, and then minus -5. So let's handle the absolute value first. Just think of the absolute value as its own set of parentheses. So in terms of order of operations, we're going to do the absolute value part here first. So in the next line, we have absolute value of -8 plus 3 is -5. So we get absolute value of -5 times 2 and then minus -5. So we work this out. The absolute value of -5 is +5. So now we have 5 times 2 minus -5. And we simplify a little more. 5 times 2 is 10. So we have 10 minus -5. And when we subtract a negative, we could change the operation here to addition and say 10 plus 5, which is equal to 15. Question 17, in brackets here, we have 12 minus -6. And then outside the brackets, we have divided by -3. So for this one here, we're going to handle what's inside the brackets first because the brackets act as a set of parentheses. So inside the brackets here, we're going to look, we have 12 minus -6, which turns to 12 plus 6. And then when we're done with that, we're going to divide all of that by -3. So we work this out. 12 plus 6 is 18. So we're doing 18 divided by -3. And 18 divided by -3 is -6 because when we do a positive number divided by a negative number, the quotient comes out negative, and 18 divided by 3 is 6. Question 18, we have -2 times in the brackets here, we have 5 minus -7, and then outside the brackets, we have +4 squared. So for this one here, we're going to start with the brackets because brackets act as their own set of parentheses. So we're going to be focusing inside here first. So we're going to have, we'll just make this a little bit neater. Inside, we're going to do 5 minus -7 is 5 plus 7. And outside the brackets, we have times -2 on this side and then +4 squared on the other side. So now in the next line here, we're going to have -2 times 5 plus 7 is 12. And then plus, now we could go from the parentheses that we did first to exponents. So we're going to do 4 to the second power is 16. And now we just go ahead and simplify here. Now we have multiplication next, and then we have addition after it. So we'll just make this so the colors pop out. See how we're doing -2 times 12, that's the multiplication, and then plus 16 is addition. So we're going to do the multiplication next. -2 times 12 is -24, and then we have -24 plus 16. -24 plus 16 is -8, and the math I'm doing in my head, I just think of -24 plus 16 as this is equal to 16 minus 24. So for this one, I'm just thinking, okay, well, 24 minus 16 is 8. So this one here is going to work out to -8. And that's our solution to question 18. Question 19, we have -4 times 2 in parentheses to the second power divided by -16. So for this one, we're using order of operations. And what we have first is parentheses exponents. So that's the part we're going to evaluate first. So we're looking at this. We have -4 times 2 to the second power. So we do the parentheses first. We have -4 times 2 on the inside is -8. And remember, a negative times a positive is a negative, and the power of 2 is just going to tag along, and we're dividing all of that by -16. So now we could focus on the -8 to the second power piece. And when I look at that, what I think of, -8 to the second power is the same thing as -8 times itself. So -8 times -8. And when you multiply two negatives, you get a positive, and 8 times 8 is 64. So -8 squared, we could say, is 64, and we're still dividing by -16. And now we could divide. A positive integer divided by a negative integer is negative. So all of this we could say at the end is equal to negative, and then 64 divided by 16 is 4. So we get -4. If we wanted to check our answer here, what we could do on the side is we could do 16 times 4 and just show that it equals 64. And if we work this out, 4 times 6 is 24. We carry the 2. 4 times 1 is 4 plus 2 is 6. So the answer here, -4, is definitely checking out. Question 20, a lot of students look at those two minuses and they say, oh, two minuses make a plus. So this is going to start off as 3 squared. Be careful. This is a very dangerous bear trap. Okay, we have to be very careful here. The order of operations tells us to do parentheses exponents first. Okay, so when I look at this, I see the -3 in parentheses and the exponent attached is 2. That extra minus in front is actually attached by multiplication. Okay, so we do parentheses exponents first. So I'll just make that a different color. So we do parentheses exponents first, then multiplication. If we want, we could see another way to read this. This is the same thing as saying -1 times -3 squared plus 18 divided by 3. Okay, so that extra minus in front is a lot like saying -1 times parentheses -3 squared. And now we, once again, start with parentheses exponents, and we do -3 to the second power first. So we do that. -3 to the second power is the same thing as -3 times -3, which is equal to +9. And we can start off by saying now -1 times +9 plus 18 divided by 3. And now from here, we just have multiplication over here, and we have division at the end. So we're going to do the multiplication first, and then we could do the division after. So let's go ahead and multiply first. So we're going to do next, -1 times 9 is -9. Okay, we're doing a negative times a positive is a negative. And then we could do division next. So the division we have here is 18 divided by 3. But these two parts here are attached by addition. So when we divide 18 divided by 3, that's going to go after the plus sign here. Okay, whatever that quotient is. But 18 divided by 3 is 6. So we're just going to write plus 6 at the end like this. So now we could simplify. -9 plus 6 is equal to -3. Question 21, we have 2 to the third power plus -4 squared minus 7. So order of operations again. And we are going with parentheses exponents first. So the -4 to the second power is the piece that jumps out right away. So here we have 2 to the third power plus, and then -4 squared is the same thing as saying -4 times -4, which is equal to +16. So we're going to have 2 to the third power plus 16, and then minus 7. And then next, we look at these three terms here. We have an exponent, we have addition and subtraction. The exponent is going to outrank the others. So next we're going to do 2 to the third power, which is the same thing as doing 2 times 2 times 2. And if I do this in pieces, 2 times 2 is 4, and then times 2 again gives us 8. So we could say in the next line here, 2 to the third power is 8, and then we have plus 16, and then minus 7. So now we work this out a little more. 8 plus 16 is 24. So we have 24 minus 7, and 24 minus 7 is 17. Question 22, we have absolute value of, in parentheses, -10 divided by 2. And then outside the absolute value, we have plus -3 to the third power. So just know with order of operations, absolute value acts just like a set of parentheses. So in this question here, we have the option of evaluating this part first in the absolute value, or we could evaluate this part. So it doesn't matter which one we do first, as long as we do both of these expressions correctly and then add their results together. So let's say we start with the absolute value. So we're going to have absolute value of, and then here, -10 divided by 2 is -5. Okay, a negative divided by a positive is negative, and then we still have our absolute value lines here like this. And then plus -3 to the third power. Here we have to be a little careful. So -3 to the third power is -3 times itself 3 times. And if we do this in pairs here, -3 times -3 is +9. And then we multiply that last -3, and we get 9 times -3 is -27. So after the plus sign here, we're going to get plus, and then the integer -27. But now we could see here the absolute value of -5 is +5. Remember, the idea of absolute value is it tells us the distance to 0, and -5 is 5 units away from 0. So now we get 5 plus -27, and this gives us -22. If we forget from before, how to do this math in our heads, when I do 5 plus -27, that's the same thing as 5 minus 27. And all I do is I just think of negative and then 27 minus 5. I just flip the order in my head. And then I know that 27 minus 5 is 22. And I just throw the negative in front like this. So -22. Question 23, we have this beast of an expression, but we're just going to go piece by piece. So remember order of operations, we always look for parentheses exponents first. So this piece jumps out right away. Negative 2 to the fourth power. This we could evaluate. I'll actually just write it over here. So negative 2 to the fourth power is the same thing as negative 2 times negative 2 times negative 2 times negative 2. And this we could go in pairs. We get negative 2 times negative 2 is positive 4. We get negative 2 times negative 2 is still positive 4. And then 4 times 4 is 16. So this starts off as 16 minus. And now this part might throw you in a bit of a loop. So what's going on here is we have parentheses, brackets, and then we have curly brackets. So the way I think of this is I almost just think in layers, that the innermost layer is the parenthesis. So we look at this first, and then we go out of that. We go to the brackets. Okay, let me just change colors here so it doesn't match what we've written so far. So we have the brackets next. So that would be up to this part. And then last, we're looking at the curly brackets. Okay, that's the outermost layer here to look at in this complicated part over here. So we have the curly brackets on the outside. And the reason why they use 3 different types of parentheses here, or ways to group terms together, is so that they don't make it confusing where the layers start and stop. Okay, so if we change up from parentheses to brackets to curly brackets, it's a bit easier to see where the layers are in the expression. So we go to the innermost and then the middle layer. So what we're going to be doing first is actually this piece here. Okay, so let me just change colors for the highlighter. We're going to focus on being in this space here inside the parentheses and the brackets. So let's go ahead and work that out. So we have in the curly brackets now, we have 18 divided by, and I'm going to write that result over here. What we have inside the parentheses brackets is 3 times negative 2, which is negative 6. Okay, just remember we have a positive times a negative is negative, and 3 times 2 is 6. So we have 18 now divided by negative 6. And then outside of the curly brackets, we still have this plus absolute value of negative 7. So now this is much simpler and we can move forward. So in the next line here, now we have, so I'll just change colors here. We have 16 minus, and inside these curly brackets, we're going to have 18 divided by negative 6 is negative because we have a positive divided by negative, and 18 divided by 6 is 3. So we get 16 minus negative 3. And then we get plus the absolute value of negative 7 is equal to positive 7. So now I'll just move this part out of the way and we'll simplify the rest here. So in the next line here, we could say we have 16 minus minus 3 becomes 16 plus 3. And then we have plus 7 at the end. So now we just add these numbers together. I just see these right away. 3 plus 7 makes 10, and 10 plus 16 is 26. So this works out to 26, okay? And I'll just write my equal signs here along the way to show we're going from one line to the next. But question 23, our answer is 26. Question 24 is another beast, okay? But we're still doing PEMDAS, so order of operations. And for this one, what I see right away is the absolute value sign. So the absolute value sign acts as its own set of parentheses. So we could look inside of this space first and evaluate these terms. So within that space, we have another set of parentheses exponents that we could talk about. So negative 4 to the third power. Something like this, what we do is we do negative 4 times negative 4 times negative 4. Okay, we just have to be careful with multiplying these negative integers here. So a negative times a negative is positive. So we're going to get negative 4 times negative 4 is positive 16. And then we multiply by that last negative 4. And then we do a positive times a negative is negative, and 16 times 4 is 64. So that last piece at the end is going to be negative 64. And then the first piece here, 5 to the third power, that one we could just say 5 to the third power is 5 times 5 times 5. And then 5 times 5 is 25, and 25 times 5 is 125. So in the first real line of work here, so now I'll just move this out of the way a little bit more. But in this first line of work over here, we could say this is equal to, and I'll change colors here. We have equals absolute value, 5 to the third power is 125. And then we have minus the expression here. I'll just highlight this with its own color, negative 4 to the third power, this piece. We're going to say negative 4 to the third power is negative 64. Okay, now here's something we have to be careful of. Don't just say, oh, wow, there's already a minus sign there for me, so I'm just going to write 64. You have to be careful. This is a very dangerous bear trap. So here, -4 to the third power, we have to write -64 like this. So we are subtracting -4 to the third power, which is -64. So we're going to have two minuses here, which is going to change to a plus sign in a bit. And then after, we have divided by -3, and then plus 2 to the fourth power. And 2 to the fourth power, I could just evaluate on the side. That's 2 times 2 times 2 times 2. And we do 2 times 2 is 4. And we have two more factors of 2 to multiply. And then we have 4 times 2 is 8. And 8 times 2 is 16. So at the end, we have 16. And now I'll just erase all this extra stuff so we have space. So now moving on, what we have next is inside this absolute value, we have 125 minus -64, which is going to change to 125 plus 64. And then after that, we're going to divide by -3 and add 16. So I'll just work this off to the side here. 125 plus 64 is going to give us, we have 5 plus 4 is 9, 2 plus 6 is 8, and the 1 carries down. So we get the absolute value of 189. So let me just clean this up a bit. We have absolute value of 189, and then divided by -3, and then plus 16. So off to the side here, well, first let's actually write this out. We're going to have absolute value of 189 is 189. So we get 189 divided by -3, and then plus 16. But what we're going to do next is we're going to do division before the addition. Okay, so division first before adding. So off to the side here, I'm going to do 189 divided by 3. So actually, I'll just move everything up a little bit more so I have space to do long division, because we have a 3-digit number here that we're dividing. So we have this number 189, and we're dividing it by 3. So 3 doesn't go into 1 because 1 is too small. 3 goes into 18 though 6 times. 6 times 3 is 18, so this divides evenly. And then we carry down the 9, and we say 9 divided by 3 is 3, and 3 times 3 is 9, so we get no remainder. Okay, so we could say in the next line here, but we just have to be careful. We have a positive divided by negatives, so we're going to have -63, and then plus 16. So for this last part here, the math that we have to do is combine these numbers, but I like to think about the flip here. So what I'm thinking about is if we had 63 minus 16, how this would work out to a positive number. So when we have -63 plus 16, this is going to be the additive inverse of whatever we get here. Okay, so let me just do that math off to the side here. So I'll just erase, and I'll also erase this section over here so we have the space to now do the subtraction. So I'm going to write out 63 minus 16, and I'll do this subtraction. And whatever we get here, our answer is going to be the additive inverse of whatever this answer is. So we're going to borrow, make a 5. So we can put a 1 here because we can't do 3 minus 6. So we're going to do 13 minus 6 is 7. And then 5 minus 1 is 4. So the difference between 63 and 16 is 47. But when we have -63 plus 16, that's -47. Okay, so that's how the last question simplifies. Once again, the thought process here, if we really want to see the technique, is when we do -63 plus 16, that's the same thing as saying -1 times, in parentheses, 63 minus 16. So now we're moving on to the word problem. So question 1, we have use a chip model. We're going to draw positives and negatives to compute. And for part A, we have -5 plus 3. So for these chip model questions, what we want to do is we want to model each number with a set of chips. So let's say we do +3 first. That would mean we have 3 positive chips. And then for -5, we would have 5 negative chips. Okay, so we're going to have 5 negatives. And I'll try to draw them like this where they're lining up nicely. So we do this, and what happens is when you have a positive chip and a negative chip, they just cancel each other out. Okay, so this is modeling -5 plus 3. So these cancel out, this pair cancels out, and we have 2 negatives left, which is why we could say -5 plus 3 equals -2. So now we could do this again, but now we're going to do it for 8 plus -6. So 8 will model with 8 positive chips. Okay, so I'm going to draw 1, 2, 3, and then we have 4 through 8 coming up. Okay, so just drawing a bunch of these out just to model the situation. So this is good because it helps you develop a strong mental model for what adding and subtracting integers actually is. So here we have our 8 positives, and now I'm going to draw our 6 negatives. So we have 1, 2, 3, 4, 5, 6. Okay, so there are the 6 negatives. And now all we do is just cancel out the pairs of positives and negatives, because a positive negative just cancels out. So we just cancel these out, and notice that we're left with 2 positives left. So we could say 8 plus negative 6 equals positive 2 using this CHIP model. Question 2, the temperature is negative 7 degrees Fahrenheit. It rises 12 degrees Fahrenheit, then drops 20 degrees Fahrenheit. What is the final temperature? So for this one here, we're going to start off with negative 7 degrees Fahrenheit. So we have negative 7, and then rise tells us to add. Okay, so we're going to add 12, and then drops tells us to subtract. Okay, so there's a lot going on here, but we're starting at negative 7. We're going up 12 and then down 20. And we want to know what is the final temperature. So now all we have to do here is just go from left to right. So first what we could do is we could add up here. We have negative 7 plus 12. Negative 7 plus 12 is equal to 5. That's the same thing as doing 12 minus 7, but we could say negative 7 plus 12 equals 5. And then we write that minus 20. And now when we do 5 minus 20, this works out to negative 15. So our final answer, what is the final temperature? The final temperature is going to be negative 15 degrees Fahrenheit. Question 3, Pythagoras was born about 570 BC. Isaac Newton was born in 1643 AD. How many years apart were they born? So for this one, what we could do is we could draw out a line like this just to model the situation. Okay, so I'm going to draw a horizontal line, and I'll put 0 over here. And anything after 0 in terms of years is AD. And anything before 0, we could say is BC. So when we're told Pythagoras was born 570 BC, let's just say that's somewhere over here. So this is going to be 570 BC. And then Isaac Newton was born in 1643 AD. So let's say that's over here. So what we could do then, now that we have an understanding of what's going on, is we could set up an integer equation here, or an integer expression that allows us to answer the question, how many years apart were they born? So we just have to be careful though. It is tempting to say 1643 minus 570. But this is a very dangerous bear trap, okay? We have to know here 570 BC is in the negative before 0. So we're going to say minus negative 570, and this is actually going to change to 1643 plus 570. And for this whole packet here, I'm doing everything without a calculator. So I'm just going to do the addition off to the side here. So I'm going to write this out vertically so we could do long addition. And now 3 plus 0 is 3. 4 plus 7 is 11. So we write our 1 and we carry the extra 1 over. And then we have 1 plus 6 is 7. 7 plus 5 is 12. We carry the 1, and then 1 plus 1 is 2. So this tells us here that Isaac Newton and Pythagoras are 2,213 years apart. Okay, so how many years apart? We're going to say, well, this is our numerical answer to this equation here, but we're just going to say at the end here, 2,213 years. So this is our solution to question 3. Question 4, a submarine is 350 feet below sea level. It ascends 275 feet, then descends 150 feet. What is its final position relative to sea level? So for this one, I'm going to draw out a line, but this time I'm going to draw a vertical line like this. Okay, so this is just to help us understand what's going on in the question. So let's just say here that 0 is over here. Okay, so this is going to represent sea level. So 350 feet below sea level is going to put us in the negative. Okay, so that's going to put us over here. So we're going 350 feet down, so this way. And so at the start of the question here, the submarine is 350 feet below sea level, but then it ascends, which means it goes up. So we could say adds 275. So it goes up and then it goes back down 150. So here, what we're going to do is we're starting off with negative 350 because we are below sea level. So this is in the negative here. Okay, so this is why we're starting off with negative 350. So if the submarine ascends 275 feet, that's adding 275. And then descends 150 is minus 150. Okay, so this is what we have to work out. So for this one, we're just going to go piece by piece. So I'm just going to move this over. And what we're going to do first is we're going to add these two numbers together. So we're doing negative 350 plus 275. Now off to the side, I'm going to do 350 minus 275 because we really just have to find the difference between these two numbers. But I know that when we add these two integers, we're going to get a negative because the absolute value of negative 350 is greater than the absolute value of 275. Okay, so we have a number that's more negative plus this number is going to stay negative after the sum. So now we just work this out. So I'm going to borrow from here. We get a 4, carry the 1 over. 10 minus 5 is 5. And then we borrow here, make this a 2. And we have 14 minus 7 is 7. And then 2 minus 2 just goes away. So we're left with 75. So we would say negative 75 would be the sum of negative 350 and 275. And now we just write our minus 150. So for this one, we could think of this as negative 75 plus negative 150. So off to the side here, I'm just going to add 150 plus 75. And if we work this out, this works out to 225. Okay, but we have a negative plus a negative here, so it's going to be a negative 225. If we have 75 negatives and we add another 150 negatives, we're going to have 225 negatives. Okay, so over here, we get negative 225. So what is its final position relative to sea level? We could say 225 feet below sea level. Okay, so 225 feet below sea level. Okay, so the question is asking relative to sea level, so that's why now I'm not using a positive. Well, I'm sorry, I'm not writing a negative here. I'm just saying 225 feet below sea level, which equals negative 225. Okay, so if we kind of follow what happened in this question here, so I'm just going to take this little piece here and maybe I could move, well, let's try to move just the point here. So I don't know if I'm going to be able to catch just this. I'll try. Oh, there it goes. Perfect. So when we went negative 350 plus 275, we went almost to 0, but then we went back down another 150, which put us at minus 225 or 225 feet below sea level. Question 5, if you owe $15 and spend $12 more, then receive $20, what is your balance? And we're going to use integers. Owing is negative. Okay, so we're just going to keep that in mind here. So if we owe $15, that's having negative 15. And then we spend. So here, once again, we are in the negative. But when you spend, that money is subtracted out of your bank account. Okay, so we have negative 15. So we're subtracting 12 more. And then we receive, which means we're going to add $20. We want to know what is the balance in this account here, or how much money does the person have. So for this, we just go piece by piece. Now, one thing that students will sometimes get mixed up with, when they hear PEMDAS and they look at something like this, they see the subtraction and they say, oh, subtraction is less, so maybe I should add first. But one thing I want to point out is that addition and subtraction are the same rank. So when that's all that's left, if all you have left is addition and subtraction, you can just go from left to right and you're going to get the correct answer. Okay, so just wanted to point that out. So here we could do negative 15 minus 12 and we get negative 27. All right, the math that I'm doing is I'm adding 15 and 12. So let me just make that neater. So we have 15 plus 12 is 27, but we have, in a way, negative 15 plus negative 12, giving us negative 27. And then we just bring down that plus 20. And from here, we just find the difference between 27 and 20, which is 7. But we're doing negative 27 plus 20, which is equal to negative 7. Okay, so what is the balance here? Well, we owe $7, or we could say negative $7 would be the balance. Question 6, a bank account has a negative $40 balance. You deposit $25, then write checks totaling $60, then deposit $50. What is the final balance? So for this one, we just have to go piece by piece. We're starting off here with negative $40. So we have negative 40. And then we deposit 25. Depositing money means adding money. So we're going to go plus 25. And then when you write checks, you lose that money from your bank account. So you are subtracting. Okay, so we subtract 60. And then deposit 50 tells us to add 50 at the end. Okay, so now all we have to do is just go piece by piece. So first we could do negative 40 plus 25. And off to the side here, I'm just going to do 40 minus 25 is 15. However, over here, since we're doing negative 40 and positive 25, we just flip and we get negative 15. Okay, I'm just using this idea. If I start off with something easy like 7 minus 5 equals 2, just know when you flip the numbers, when you do something like 5 minus 7, it's the additive inverse or matching opposite of this number. So we get negative 2. Okay, and that works every single time when you are subtracting integers. So for something like this, I'm reading that in my head as 25 minus 40. So I just do 40 minus 25 and take the opposite. So now we could write the rest. We have negative 60, or we have, so now we have negative 15 minus 60, and then we just write that plus 50 at the end. So now for the next piece here, we are doing negative 15 minus 60. And for that, I'm really just doing 60 plus 15 is 75. So we get negative 75 and then plus 50. And for this piece here, we're just going to do 75 minus 50 is 25. But then we're using the same idea as before. This is going to work out to negative 25. So what is the final balance? The final balance here, we could say at the end, is negative $25. So here is our solution to question 6. Question 7, a submarine is at negative 450 meters and dives another 80 meters. Write an inequality comparing its starting and ending depths. So for this one, we're starting at negative 450 meters. Okay, so this is the starting depth. So we're going to write negative 450. And then the submarine dives another 80 meters. So in terms of integers, this is subtraction. Okay, so we're going to subtract 80 meters. And I'll write all the units out at the end. So now we have to just work this out. This is the same thing as negative 450 plus negative 80. So off to the side here, I'm just going to go 450 plus 80, and that'll tell us what our ending depth is over here. So 0 plus 0 is 0. 5 plus 8 is 13. So we write our 3 and carry the 1. And then 1 plus 4 is 5. So the ending depth is going to be negative 530. Okay, so we'll say that the ending depth is going to be negative 530 meters. And now, just to get a visual of what's happening here, so we'll just say over here, let's say that's sea level. So this is sea level. And then we're going from here. And this is going to model the submarine going underwater. Okay, so let's say at the start of the question here, 450 meters under is going to be somewhere over here. Okay, so this is the start of the question here. So we're at negative 450. And then let's just say, well, I should have practiced how to draw a better submarine, but I don't know. Let's just say this is our submarine over here. So the submarine dives another 80 meters. So it goes down more like this, and it lands at negative 530 meters. So at the end, we actually have to compare the starting and ending depths. Okay, so this is the start, and this is the end. So here, when we write out our inequality here, we're going to say that negative 530, the ending one, and I'll throw the units in here too. I'll say negative 530 meters is less than negative 450 meters. Okay, so this is a smaller integer, a lesser integer, because it's dropping down like this. All right, if you wanted to see this on a horizontal number line, so let me just first write this out like this, or I'll just circle our answer so it's obvious, what our answer is here. But if the vertical line is not making sense, I'll draw out a horizontal line to help this make sense. That let's say 0 is over here, and I start going backwards by 100. So I have negative 100, negative 200, negative 300, negative 400, negative 500, and then finally negative 600. That negative 530 would be somewhere over here. And negative 450 would be over here. So you see how negative 450 is more to the right. So negative 450 is greater than negative 530. Or we could say negative 530 is less than negative 450. Okay, so this inequality works out. Question 8, find two integers whose sum is negative 2 and whose product is negative 15. So for this question, we just have to be careful. It is tempting to start off with trying to find two integers that have a sum of negative 2 first. But please don't do that, because you will spend a really long time writing out the list of two integers that have a sum of -2, because the list of integers that add up to -2 is infinite. Okay, I could just keep doing something like this. Like, let's say I go up 1 in this direction, and then I go down 1 in the other direction like this. And this list would continue forever. Okay, so we're not going to start off with the two integers that have a sum of -2. We're going to start off with the pairs of integers that have a product of -15, because that list is finite. When you think of the numbers that multiply to 15, you have 1 times 15, and then you have 3 times 5, and then this is it. Okay, we could keep checking for more, but these are the only integers that actually multiply to 15. However, what's going on here is we are actually multiplying to -15, which means one of these numbers has to be positive and the other has to be negative. So here I could start off with, let's say, -1 times 15 and -3 times 5. But then when I continue my list here, next I could say +1 times -15, and I could say +3 times -5. So now what I have to do is I have to find which of these pairs also has a sum of -2, because all of them have a product of -15. But the math I have to do in my head now is I have to add those pairs of integers and see which one works out to -2. So if I add, let's say, the first pair, -1 plus 15, if I add instead of multiply, gives me 14. If I do -3 plus 5 for the next one, that gives me +2. So now I go on to the next one here. 1 plus -15 is -14. And then we have 3 plus -5 last. That's the one that works out to -2 as well. So you see how these four pairs all multiply to -15, but only one of them also has a sum of -2, which would be the last pair. Okay, so the two integers, I'm going to write them in curly brackets like this, are 3 and -5. Question 9, the opposite of a number is 14 less than the number itself. What is the number? So for this one, I'm going to do this two ways. I'll do this with and without algebra. But first I'll do the non-algebraic way. So I'm just going to draw out a number line here so we could just break this down just to see what's happening. So here we have 0, and we're told that the opposite of a number is 14 less than the number itself. So if we look at, let's say, 1, the opposite of 1 is -1, but these numbers are 2 units away. See how these are 2 units away from each other. And then let's say I'll go out a little bit more. I'll go out to 3. So I'll say 3 is over here. The opposite of 3 is -3. And these numbers are 6 units away from each other. See how I have to go +3 to get to 0, and then plus another 3 to get to 3. So you might start to see the trend here. If I look at this, I say the opposite of 3 is 6 less than the number 3 itself. So 14, you see there's a times 2 pattern happening here. So the math I'm doing in my head here is I'm saying, wait a minute, what if I take 14 and I divide it by 2? This is going to work out to 7. So now I'm tempted to try out what happens if I use 7. So I'm just going to bring this down a little bit so we have the space to see. And we go out to 7. So we'll write our 7 here. And then we think the opposite of the number 7 is the number -7. And then how far away are these two numbers? These two numbers, I'll make that a little bit neater. So these two numbers here are 14 units away from each other. I have to go +7 to get to 0 from -7, and then plus another 7 to get to +7. So now we run this through. The opposite of a number is 14 less than the number itself. So the answer has to be 7 here, because the opposite of 7 is -7, and -7 is 14 less than 7. If we want to check this, we could even see here that if we start off with 7 and we go -14, we get -7, and this is the opposite of 7. Okay, so this value here, 7, is definitely checking out. Now, for option 2, we could just use algebra. Okay, but depending on where you are in your schooling, you may not have learned this technique yet, but this is just an alternate option. to see that instead of breaking this down conceptually with the number line, that you could just set up an equation and solve. So here in math, the word is means equals. So if I say the opposite of a number, so let's say the number itself is x. The opposite of x would be negative x. So I would say negative x is, so the opposite of a number, so the number x, the opposite of that is negative x, is means equals 14 less than the number itself. So I would say x minus 14. When you say 14 less than, that tells us to switch these two quantities. So switch, and let me just make that neater. So switch and subtract. Okay, so we switch and subtract. And now if we work this out here, so I just solve for x, I could go minus x on both sides. So x minus x cancels, and then I have negative x minus x is minus 2x. So this is why integers are so important, because when you move on to algebra, you have to be able to work through these equations here nicely. So the math I'm doing in my head, this is a negative 1x. So there's an invisible 1 here, but this is negative 1x minus 1x. So I do minus 1 is negative 2. That's why I have negative 2x. And then this equals negative 14. And let me just make some space here. So I'm just going to move this down over here. Let me actually leave that original 7 behind though. So we're going to go this, we'll just put this over here. And now we could close out the algebra. So now to get rid of times negative 2, because this is negative 2 times x is negative 14, we just divide both sides by negative 2. And then x equals positive 7. Okay, so this algebra would be pretty tricky to set up depending on, where you are in your schooling. Eventually this will be okay. But even so, even with algebra, this is like a bit of a tricky question. But using the number line here and the concept of integers and the concept of matching opposites or additive inverses, we can use logic and look for patterns to get to our answer. And our solution here is 7. Question 10, the product of two integers is 48. Both integers are negative, and we have to list all possible pairs, then find which pair has the smallest sum. So for this one, we could start off by listing the pairs of numbers that multiply to 48, but we're listing the pairs where both integers that we're multiplying are negative. So we could start off here with negative 1 times negative 48. And then we have negative 2 times negative 24. So when we have both integers are negative, remember a negative times a negative is a positive. So this list that we're making so far is fine. And then if we look at negative 3 next, negative 3 would multiply by negative 16 to make positive 48. So this trick that I'm using, how I know 48 is divisible by 3, is I use the divisibility by 3 trick, which is when you take the numbers in any number, like let's say 48, and you add the digits together, whatever that sum is, if the sum of those numbers is divisible by 3, which 12 is divisible by 3, so is 48. And then I could just do 48 divided by 3 is 16. So we say negative 3 times negative 16. And then next we have negative 4 times negative 12. If we go to negative 5 next, that won't work because 48 does not end in 5 or 0. And then we look at negative 6. We would have negative 6 times negative 8. 7 won't work, okay, or negative 7 won't work. If we look at negative 8 next, then it loops us back to negative 8 times negative 6. So this is the pair here, okay? So this would give us the pairs of numbers that multiply to 48. So now what we want to do, though, is we want to consider the sum of those numbers next, okay? So list all the possible pairs, then find which pair has the smallest sum. So over here, I'll just call this column the sums. So now we're just going to take each pair of integers and add them. So we have negative 1 plus negative 48 is equal to negative 49. Okay, so I'm just doing 48 plus 1 is 49, but putting a negative in front. And then next I would do negative 2 plus negative 24, which is equal to negative 26. And then we have negative 3 plus negative 16. And let me just make that a little bit neater. So we have negative 3 plus negative 16 is equal to negative 19. And then we have negative 4 plus negative 12 equals negative 16. And then finally we have negative 6 plus -8 equals -14. Now, if you go through this question too quickly, some students might just jump to the last one and say, oh, that's the smallest. But no, be careful. This is a very dangerous bear trap. Remember, with integers, negative integers are smaller as the absolute value of the number gets bigger. Okay, so just think of this in terms of owing money. It would be worse if we owed $49 than if we owed $14. I mean, no scenario is ideal, but owing $49 is worse than any other scenario that we have here. Okay, so which pair has the smallest sum? We would say -1, or I can just write it out like this. So -1 and -48 have the smallest sum. Okay, so this is us just writing out our answer more formally here, but this is our answer to question 10.